and students. So we will go in turn, and I will try to just alert the speaker of the remaining time. Like I will raise my hand like 2 minutes before the time is up. And so keep it a bit like high level abstract, because 15 minutes is not a long time, and allow for at least a question or two. All right, so our next speaker is Robert Rovetto. He will be giving us a talk about space ontologies that he has been working on. Okay, Robert, the floor is yours.
Thank you. Trying to share the screen. Can you see this?
We can see your screen. Yep, go ahead.
Trying to put it into full screen mode. Can you see it now?
We still see it in the regular mode.
Does anybody know how to put it into full screen? On my screen, it is full.
It's like you have to change which screen you're sharing with. Right now, it seems like you have two screens or two monitors, and you're sharing the monitor that shows PowerPoint, not the one that shows the full screen. And I think in PowerPoint, there may be like a way to swap which screen you use for in presentation mode. But exactly how to say that, to do this.
You can also share live. Like there is in the share, there is something called share live, where you can browse the slides and just upload them. This way, I think it's easier also and more efficient for PowerPoint.
Where would that be?
Just share and then go to browse my computer down like at the end, and then just select the PowerPoint slide.
Robert, I recommend you just share the way you did before it was visible.
All right. All right. I think for the talk, that's very interesting. I'll be speaking about this for spaceflight and astronomy. Unfortunately, without the say again.
We see your screen fine. Yeah, go ahead.
Okay. Unfortunately, without the animation, I'm going to I might have to move some things around. So I focus on three disciplines, what I call abstraction modeling, which includes ontology development, interdisciplinary space research, and maritime operations and safety, which are specifically in operations, not on research. Today's talk is about the combination of the first two, abstraction modeling to space research. So very briefly, I will leave this bio to another time, but suffice it to say, my past studies are via philosophy department with interdisciplinary topics. I have affiliations with both space, maritime, and ontology disciplines. These links, which I'll put into the chat, are some ongoing projects, all of which are open to formal partnerships and support. For this particular project, it's the development of a set of modular reusable abstract models for spaceflight and space sciences. The aim is to address the need for actionable awareness of the space environment by applying abstraction methods to these topics, enabling stakeholders to see the connections and gain new knowledge in the respective disciplines. This should in turn help them make informed decisions towards safer and more secure space operations. The reasons for this project are historical ideation on my part since 2011 and a personal passion for the space topic, as well as the identification of a number of gaps with respect to these types of abstract models in the sector. So currently it's a small team that is open to formal support and partners. It's for yourselves, for data and artificial intelligence persons, for stakeholders and decision makers of all sectors, from civil to military to industry and academia. And the partial approach involves conceptual analysis and development operations. It does need funding and investors, subject matter experts. And some of the goals include the use of models to support characterization and attribution in the space discipline, as well as improve decision support therein, and the development of the first tentatively open source suite of space ontologies, with interest, however, in commercialization. This is an old, about 2019 presentation slide I gave. This depicts some of the in-progress models you can recognize some systems engineering languages as well as others. And this ranges the gamut from spacecraft systems to orbital mechanics. The approach for the modeling and for the project is starting at the bottom, conceptualization, combination of conceptualization and appeal to our natural language understanding. That is, once the conceptual modeling is done, it's formalized in symbolic logic, which is then implemented in various modeling languages, including OML. And this is for compare and contrast what the conceptualization looks like across different implementations. Following that, there's non-modeling systems development support, which involves programming and simulation. And this is an area that I'd like to highlight as an area for collaboration. This is where I would like to find partners and industry providers and subject matter experts to help with these two top layers of the approach. The data flow and also an extension of the approach moving from the left at top of the screen. So data sources, various space data sources, moving to the given ontologies or semantic models. That goes into a loop, which involves the annotation and description of the data, followed by querying the data and yielding answers or results that should inform stakeholder decisions. So it moves from data to information to analyses to knowledge to decisions. This is a list of the domain ontologies, non-exhaustive list in progress, and they range from spacecraft to, as mentioned earlier, orbitology, various activities and maneuvers by spacecraft, planetary types of ontologies, and more specific subdomains such as orbital debris. And for each of these, a ontology specification document exists, and which outlines, according to the NEON methodology of ontology development, the various details of the ontologies. As an example, the orbit ontologies consist of both generic and specific layers. The generic or top level ontology of orbits is an ontology design pattern, and this provides the most abstract concepts of orbits that can be applicable to various senses of the corresponding term. At the specific level, or more domain-specific level, is the celestial orbit ontology, also called astronomical or gravitational orbit ontology, and this captures what are familiar orbits of things, of planetary objects and so forth. And this particular ontology project consists of concepts and vocabulary, as well as taxonomies, and a layer higher formal ontology for these concepts. This is also an animated slide, but moving from left to right, we have a taxonomy of the CCSDS data messages. CCSDS is the Consultative Committee of Space Data Standards. I'm a member of some of the working groups here, and they develop international standards for spaceflight. And for each one of these data messages, I've created an in-progress creation of what I call the orbit data family of knowledge models or ontologies. And so on the right, we have each one of the CCSDS data messages as ontologies, and that is combined with the previously mentioned orbit ontologies to sort of create a nice working family of orbit data models. Another aspect of the project is spacecraft ontologies, so both individual and distributed space systems. Again, at the generic layer, I've created a top-level ontology for spacecraft. At the domain-specific layer, I've created a working ontology of spacecraft and their subsystems. And the idea for these two previous examples, orbits and spacecraft, is to identify potential interest in the room and elsewhere of applications and use cases for these ontologies. So perhaps your specific enterprise models or enterprise data might be a way that we can collaborate. Moving or following that with the spacecraft ontology, here are some screenshots from a presentation I gave to the German DLR on spacecraft categories, characteristics, and subsystems. And this is visualized in the Protege development platform. What I'm working on now at UNSW is targeting specific types of scenarios in spaceflight. So moving from left to right, we have orbital collisions. In the middle, we have proximity operations. And on the right, we have constellations of spacecraft or a form of distributed space system. And this is toward categorization, characterization, and decision support. And it involves a number of observations, intelligence, and the concepts of belief, justification, and decision. So taking the second example, rendezvous and proximity operations in spaceflight, where multiple spacecraft are involved. This part of the project involves unpacking the domain concepts, conceptualizing this sort of scenario, categorizing the various types of proximity operations, and explicitly formalizing it with the goals of identification of rendezvous and proximity operations based on spaceflight data and attempting to determine behavioral patterns and intent toward supporting stakeholders to make decisions on how to act in these environments. So bringing it all together, here's a separation of concerns. So each subdomain is grouped, and each of the relevant data sets or each of the relevant types of data for those subdomains are considered and help inform these models. And again, the three scenarios are tied in with this for hopefully making better decisions for stakeholders in the sector. As a call to action, I'd like to invite everybody to help support this work in various ways, as a financial patron to co-write grants for funding. If you have your own tools, if you have your own languages, please, it would be fantastic if you can offer licenses or trainings so that perhaps this suite of ontologies can be modeled in your language or via your tool. Offer any modeling expertise, any ontology expertise, any language-specific expertise, any spaceflight expertise. Offer PhD studentships or employment. I'm open to both. I'm also an independent contractor. And if you enjoy any of my other projects on the links I'll put in the chat, please reach out to me for that. So thank you for your time.
Thank you, Robert. Is there any question for Robert? I have a question.